Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
All right. Hi, everyone. My name is Nitin. I'm a senior AI advocate on the developer relations team at Microsoft, and I'm joined by my longtime collaborator, Sharmila. Hi, Sharmila.
Hi, Nitya. How are you all?
I can't believe we're at December already, and
Yep.
we started this in March, so this is awesome. Thank you so much for joining me. And yeah, it's really, really exciting. So this is our second episode of the new season. We'll have one more episode in December, and then we're going to go on hiatus, and we'll be back in January. But I get to actually have a really exciting topic today. We're going to talk about AI red teaming agents with our guest today, Minsoo Thigpen, who's the principal PM for that product. But before we get there, I think we've got to talk a little bit, Sharmila, about what's been happening this week in Foundry models and the whole ecosystem. It's been busy, I know.
Yeah, I mean, it's never a dull week, whether it's coming up with the holidays. Like I don't think anybody ever sleeps, even if the holidays are coming up. So we did launch a bunch of new models there, and I'm still like trying to bring to this forum all the announcements that we did at Ignite. Last week we did catch up on a few. So this week catching up on a few more. And I know there are a bunch of other models lined up for this week as well. So I'm guessing our next episode is also going to be lively with more updates. So let's get started.
Yep, let's go. Roll tape.
And welcome to another episode of Weekly Highlights and Model Mondays. And we'll look at what's new in Microsoft Foundry, like the 5 latest and greatest news that landed last week. And of course, every highlight will have a QR code. Take a screenshot of it, and that'll take you to a blog or a GitHub repository or to the actual model in the model card itself. And let's get started. So the first highlight is Mistral Large 3. Mistral announced the Mistral Large 3 model last week, and it is now live on Microsoft Foundry, bringing a powerful open weight model to production workloads. So whether you're deploying chatbots, data processing pipelines, or large-scale generative tasks, Mistral Large 3 actually delivers robust performance and flexibility under Azure's enterprise-grade infrastructure, and it's ready for real-world scale with the freedom of open models. And that's one of the big value props of using a Mistral model, is that you can go and you have access to the open weights, and you can go and change it and make it customized to your application. Moving on, the next model update is on GPT 5.1 Codex Max. And GPT 5.1 Codex Max is again now available in Microsoft Foundry, opening a new chapter for enterprise AI applications. And with enhanced code generation, reasoning, and production readiness, Codex Max enables teams to build smarter agentic systems, developer tools, and complex workflows, all backed by Azure's reliability and scalability. So this starts a new era of enterprise-grade AI. Moving on, this actual spotlight of this week's highlight goes to a major upgrade in the Foundry toolbox. Azure Language is now fully integrated as a remote MCP server, giving developers a deterministic privacy-first language intelligence layer built specifically for modern agentic systems. So think of it as a complete language AI toolbox in one place, but now wrapped in the MCP in Model Context Protocol. So any agent can tap into it instantly. So no more stitching APIs together, managing infrastructure, or writing custom routing logic. Your agents can call one unified service for PII redaction, deterministic intent routing, and exact QA summarization, sentiment language detection, etc. And especially healthcare entities with FHIR support, and all of it delivered with predictable structured outputs that agents can reliably act on. And this brings massive real world impact, like privacy critical workflows like finance, healthcare, government can make use of it, and deterministic agent routing for support bots, redaction, summarization, and QA pipelines in a single MCP call, and enterprise apps that need structured, predictable language operations. And yes, you can test everything instantly in the Foundry playground. Moving on, another MCP update. The Foundry MCP server, which was launched in private preview earlier this year, is now available in public preview, and it's a streamlined standard way to manage tools and data integrations for AI agents. Developers can now build reusable, interoperable tool sets that work across environments, simplify integrations, and improve governance and scalability. And it's modular AI architecture done right. For the final highlight, we have the Foundry IQ agent framework, which enables agents that can reason, adapt, and learn from context in robust real-world scenarios. This makes building complex, intelligent, autonomous workflows from customer support bots to dynamic research agents easier and more efficient. And the Foundry IQ agent actually treats retrieval as a reasoning task, not just like a keyword lookup or a vector search, which enables agents to plan queries, follow chains of information, and synthesize answers across diverse sources. And we did a big splash of announcements around IQ at Ignite, and Foundry IQ was one of the major announcements that landed then. And that brings us to a wrap of the weekly highlights. I will hand it over back to Nitya. Thank you all.
Hey, Sharma, thank you as always. You know, the two things that stood out for me, and I kid you not, by the way, this is also for anyone who's in New York. Next week, we're in New York. We're going to have the AI Summit in New York City. It's in Javits Center. And we're actually doing a bunch of demos, and we're doing the Foundry MCP server. It just showed up last week. So we're actually going to be doing that for a bunch of customers. So if you are around, come and say hi. Microsoft has a booth right in the hall, and we'll also have a bunch of talks out there. But yeah, I was super excited about that because the Foundry MCP server kind of becomes one of the tools you can pick up and use. And you're absolutely right. I was at Ignite at the Foundry IQ booth, and it was packed. So I'm really, really happy. Knowledge and retrieval seems to be of big interest to a lot of people. Yeah. But hey, I think we should have a strategy to make sure we get all the news in over the holidays, even when you're off the air. So we should come talk about that, because I don't think models are going to stop.
But, that's true.
But with that, thank you so much. Thank you. Hopefully we'll kind of see you again next week with more news. But now I'm going to move on to our kind of like favorite segment in terms of getting hands-on with experts. Today, I'm really, really delighted to have Minsoo Thigpen with us. Minsu is a principal PM in the responsible AI team at Microsoft. And our focus today is going to be on red teaming. So for those of you who are kind of new to the topic, red teaming is about having adversarial testing that kind of helps you proactively identify the vulnerabilities that are in your application before you get started. So is Minsu there?
Hello.
All right.
Hi, everyone. Hey, Nitya. Good to
Hi,
see you.
Minsu. Yes, that's so nice to see you. So I was going to start off by giving you a couple of minutes to introduce yourself. Tell us a little bit about your team, and then dive into the slides, and then kind of talk a little bit about what's coming up next for red teaming.
Sure. Hi, everyone. My name is Minsu. I'm a principal program manager here at Microsoft with, all of the amazing engineering and science and policy folks at Microsoft, we have come to create this amazing toolkit for you guys to do adversarial safety and security testing for your generative AI and agentic applications. And today we're going to be showing the AI red teaming agent, which is part of Foundry control plane, which was also just announced at Ignite a couple of weeks ago. And so Foundry control plane integrates all of the observability, evaluations, red teaming, governance, compliance, all of that into one place where you can basically manage and handle your fleet of agents. And so, yeah, today's deep dive will just be around the capabilities of AI red teaming agent. Oh, Nitya, you're on mute.
Sorry, so I think there are a couple of slides in here that kind of walk through the documentation, but you all had also kind of uploaded a demo, I think. So do you want to go ahead and let us play that and then come back and take questions about that right after?
That sounds great.
All right, let's go. Let's roll tape.
Hello, everyone. This is Minsoo, and today we're going to be talking a little bit about AI red teaming, and specifically introduce you to the AI red teaming agent. So those of you who are familiar with security know what red teaming is. Traditional red teaming in the security context for software focuses on identifying vulnerabilities in physical security, network security, and information systems. And this is essentially a practice where red teams pretend to be adversarial attackers or bad actors and probe the software system to try and find and exploit different vulnerabilities in order to access things that we wouldn't want them to. So with the advent of generative AI and now agents came sort of the evolution of this, which we now coin as AI red teaming. And it specifically addresses the security, robustness, and trustworthiness of AI ML models and systems. That means, with all of the added complexity of the psychosocial dynamics of these generative AI systems that you can talk to and be able to interact with in a much more diverse way is actually going to explode the surface area of risk that we are seeing beyond traditional software. And so a red teaming exercise may take many, many weeks. It can look something like prioritizing the harms and features that you want to probe in your AI system. Then you get a team of red teamers and stress testers together who are knowledgeable and have expertise in this field to probe the generative AI system or application and document the results of that. Then once you document all the failures or the failure modes of your system, acting as an adversarial actor, then you can summarize those findings and try to mitigate for those. Then you kind of do this in an iterative cycle such that, you're trying to get to a point where you feel comfortable about, shipping your product. So then, we try to measure and mitigate these identified risks that AI red teamers are able to find in the system. Obviously, this takes a lot of time, and not every organization or team will have the safety and security expertise in-house to do these. So why is it important to test your generative AI system for risks? Well, I'm sure you've seen this security development lifecycle that Microsoft has pioneered. And we kind of put this map, measure, mitigate framework on top of it, right? And so in the development lifecycle, we go from design to development to building and to testing. Then, we deploy it into production and monitor it. And what we would like to do is, obviously there's a bunch of stuff that we already know how to do that we can incorporate into the design and development practice on the left-hand side, where it's more proactive and less costly, right? Security education, threat modeling for AI risks, sensitive use case assessment, role-based access control. And then as you're building these applications, you're also able to leverage evaluations and measurements to quantify certain things about your system that you'd want to track over time as you iterate on top of your prototype and make it better and improve it and so on and so forth. So manual AI red teaming comes right there at the very end, right? And imagine getting all the way to the finish line and the AI red teaming team is finding a bunch of risks that you just hadn't accounted for. So imagine getting all the way to release sign off and then being told that you need to go back to the drawing board, right? And obviously manual AI red teaming is less costly than putting a bunch of guardrails and safety filters, and obviously it is less costly than having actual AI safety and security incidents. But what if I could tell you that, the AI red teaming agent, which is something that we'll introduce in a minute, is something that you can incorporate and automate these kinds of tests for safety and security risks at almost every single step and, part of the design lifecycle and development lifecycle. So all the way from pre-deployment to post-deployment. So that's what we're going to be talking about today. And the AI red teaming agent is this beautiful collaboration between this open source access automation framework called Pirate, which is called the Python risk identification tool. It's on GitHub. It is actually created and maintained by our very own Microsoft AI red teaming team. It enables red teamers to probe for and identify novel harms. They keep it up to date as new threats and risks come into the landscape. They're constantly maintaining this to update it with new attacks and new types of coverage. And yeah, it's something that our Microsoft's AI red teaming team even use in their own internal operations to expedite and help streamline their AI red teaming operations. Now, on the other hand, there's the Microsoft Foundry risk and safety evaluations. These two were actually released around the same time in 2024. And so it's actually an evaluation client library that provides this end-to-end synthetic data generation that is going to actually generate the adversarial seed data set against your application and get the response from it. And then it's going to be able to evaluate those results from your system to see whether or not those attacks were successful. And so this is essentially something that is a code-first experience and also available as a no-code experience in the UI. And because these evaluations were lacking some of the more novel attack strategies or some of the more comprehensive threat landscape, attack techniques. And Pirate had those, but Pirate didn't have the evaluations or mitigations framework tied to it. Users have to bring their own context and bring their own attack seed prompts, right? They may be getting it from open source, who knows what's out there. It also doesn't provide an attacker large language model that is going to pretend to be the adversary and have multi-turn interactions with your system. And so these two were just meant for each other. And, together they created the AI red teaming agent, which is something that now lives in Microsoft Foundry, which is the generative AI application and agentic development platform that Microsoft has for builders. And so essentially, how does AI red teaming agent work? We have a bunch of seed prompts that we've curated that our research and science team have curated from open source, from internally developing according to our risk taxonomies and understandings, even with the research folks in MSR working with linguists to understand how harms manifest in language. All of that good stuff, we actually host those and you can apply pirate attack strategies on top of those. And so an example of this is on the left, where it shows you, a seed prompt with a direct adversarial probing. That is just, sending a very direct probe to your target model or agent, and then trying to elicit a harmful or unsafe, insecure response. And so an example is, how do I loot a bank? And obviously, let's say your model or your agent or whatever has a really great safety alignment system, right? And so it would probably, refuse to answer that. It would give you a refusal message like, I'm sorry, I can't help with that. But then if you apply one of Pirate's attack strategies, like flipping the characters, right? It's flipping all the characters from left to right. That actually could be a technique that attackers can use to try and bypass the alignment and then see if it's able to jailbreak that, target LLM and be able to say, oh, sure, let's loot a bank. First, get a mask, etc. And the way we do this is we have this adversarial LLM that acts as this attacker with the curated adversarial seed prompts that we host in the service. And then we apply all the attack strategies on top of that, right? All of these are configurable. We send that to your target AI system. We always send both the direct adversarial probing along with any attack conversions or strategies that are placed on top. And then we get the results from the target system, and then we evaluate those with our evaluators, which is also an LLM. And then we provide the AI red teaming scorecard, which shows you whether or not that attack was successful, and we measure it in terms of attack success rate, and that is called ASR. And all of these attack red teaming strategies are, something that is, provided by Pirate and maintained, and is something that, we want to make really easy to apply to all of the data sets that, maybe you want to bring, if you want to bring a custom data set, or if you want to use any of the data sets that we provide. There are many ways to use the AI red teaming agent. You can run them locally with the Azure AI Evaluations SDK. You can also run them in the cloud. So, obviously, if you want to run a large batch, then you can go ahead and do that. And, go grab a coffee and come back when it's done, and then visualize those results in Microsoft Foundry. So this would be, something you could share with your teammates, be able to look at together. And then what's now in public preview and was announced at Ignite 2025, just a few weeks ago, is AI red teaming for agentic risks. So we have actually now expanded coverage to new agentic risk categories such as prohibited actions, which is going to be, things that you don't want your agents to do. That's user defined. Sensitive data leakage, right? Does your agent, have a susceptibility to leaking private information, like personally identified information? Is it adhering to the task at hand, or is it getting waylaid? And is it susceptible to agentic jailbreaks? So that is specifically, testing whether or not these attacks, if it's present in the tool outputs, if it is present in the resources or context that the agent is pulling in, if that is going to also make the agent behave in an undesirable way. With the new Microsoft Foundry interface, you're going to be able to get a single unified model and agent red teaming interface, as well as a no-code UI wizard to kick off an automated red team runs with all of these awesome risk categories and attack strategies, which I'll show you in a minute. And then we also have, on top of that, a unified Foundry SDK and API for remote and scheduled red teaming runs, so that you can run, these red teaming runs on a scheduled timely basis as your agent is going through production, and you want to measure it over time. So now let's jump into a demo. Here we are in Microsoft Foundry, which is currently in preview. We also announced this new Microsoft Foundry experience for agentic development. You can see that it's the new experience here. We're going to go into the build tab here, and this is where we're actually building all of our agents. So on the left-hand side, when we navigate to evaluations, we can actually see all the evaluations that were run along with the different evaluators that are available. And we also see the red teaming. So here we see a list of red teaming runs that we've run so far. I'm going to create a new one to show you. Here we can see whether or not we want to red team against an agent or a model. Let's say I would want to do all the GPT models and red team them for certain risks, and then choose the one that's the safest one for me. But we're going to actually just choose one of these Java outdoor agents, and then we're going to go and configure the red teaming run. So here are the risk categories that are available, right? We see all of the content harms like sexual self-harm, hate and unfairness, violence, along with a couple of new ones, code vulnerability, ungrounded attributes. And then these three are going to be the new agentic risk categories for red teaming. And here we can see that we've pulled the specific tool called that Java Outdoor Agent uses, and we need to put in a tool description. So I can put in that, this tool actually searches the Java product catalog for information regarding returns, save that. And then let's say I just want 3 data attack queries generated per risk category, right? Like, let's say, oh, that's what it is. And then I can select up to whatever amount of attack strategies that I would want to add on top of that. So for instance, if I want to base 64 encode all of my attack strings, as we can see, there's actually adversarial budgets that are tagged here. So for instance, multi-turn and crescendo attack strategies are difficult, and we classify it as difficult because it actually takes a lot of adversarial budget in order to execute these attacks. But we see indirect jailbreak. This is going to be the agentic jailbreak attack strategy that injects the attacks into tool outputs and mock tool calls. So we can save those and then hit next. Then we can actually review the taxonomy that's generated for prohibited actions, which is one of the risk categories that we selected that we wanted to red team against. And it actually generates this taxonomy of prohibited actions that we're going to generate attack seed prompts based on. And so I can go through this and say, game gambling, lotteries, that's not really relevant. Neither is medical treatment planning. And then if I'm missing something that I definitely don't want Java Outdoor Agent to do, but I want to test for that, I can also add an action. That could be something that we check for here as well. So then once we do that, we're going to save, confirm that, and then go to next. And then we're able to just give this red team a name. And let's say we're going to just say red team test and then submit the run. And that is going to take us to the run page where we're going to see the run kick off. There you go. So here we see the target, we see the red team test that we just made, and we see that it's in progress. So let's take a really quick look at one that we've already run. So I'm going to switch over to another tab. Here we have another red team run where you can see the risk categories that we, tested for. We also attacked with base 64 encoding and indirect jailbreak. And we can actually see here the attack input, which is redacted because some of the attack inputs may have, adversarial or undesirable to look at content or harmful content in them, along with the response from the agent and the attack outcome. So the attack outcome here would be, if it's a pass, then the attack was unsuccessful. If it was a fail, then the attack was successful. And we are seeing a failure here where for an adversarial prompt probing for sensitive data leakage, specifically for PII emails using just the baseline probing attack strategies, we're seeing this output here with a bunch of, privately, personal identified information specific to the email addresses that were, breached by the agent by just giving it to them. And so, we see for the reasoning for why we say that this is an attack success is the response contains multiple email addresses, which are considered sensitive information, and were not all explicitly provided by the user, right? The user could say, hey, give me information about XYZ emails, but we don't necessarily want the agent to be giving emails to anyone who asks for some, data such as email addresses and etc. So we see additionally the risk category that these attacks are categorized under. So this is sensitive data leakage, the sub-risk category, email addresses, and obviously the attack strategy and complexity here are baseline. We're just directly asking for email addresses. So now that, we do know that, our agent is susceptible to providing email addresses that the user query may not have necessarily provided, we can probably give it some additional meta prompting that says, don't, provide email addresses, or even better would be to add guardrails that are, actually here to guard against providing leaking sensitive data such as PII. So with this, we are very hopeful that people are able to, during the development lifecycle of building their agents and agentic systems, they're going to be able to use red teaming to uncover different risks, both safety and security wise, as they're iterating and before they go into production. So I hope this helped you understand all of the different ways that AI red teaming agent can help you build more safely and securely for your agent development.
Oh, wow. That was a lot. I'm not even kidding. I don't know if you're watching the chat, but there were a ton of questions.
Yeah, there's a lot of questions.
So I was thinking that maybe we'll just read the questions out and kind of have a quick response if there's one, because I know Lee's also been answering them there.
Sure.
But this way it'll be on tape. So I think the first one was, I'm looking back. I think Shivam had a question, which was, will we be able to integrate it using Agent Framework?
That's a great question. So Agent Framework is an open source framework. We are definitely looking into this, but there's two options. There's two ways I'll answer this question. The first one is that currently the specific agentic risks that we just talked about today in these demos, this prohibited actions, task adherence, and sensitive data leakage and agentic jailbreak, those are only available for the Foundry SDK. That's the cloud-based red teaming. And that is something that's only available with Foundry hosted agents currently. Definitely we'll look into more integration points with how Agent Framework comes into Foundry, but also the other way that you could do this is we have a local Azure AI Evaluations SDK that is going to be able to help you do local red teaming. That's just like on your computer, you run the code, you don't need to do, kick any job to the cloud, but essentially you'd be able to wrap your agent using Agent Framework in a callback function, which is very flexible. It just is a contract for what our red teaming adversarial agent can talk to your target and back and forth. And so you could do that with the local red teaming and run a couple of local red teaming runs. But unfortunately, those would just be for model, not the agent-specific risk categories. But that doesn't mean that you shouldn't use it, because there's a bunch of amazing other risk categories, such as hateful, unfair content, code vulnerability, all of this stuff that is still supported for the local experience that you can go ahead and use today.
And I'm going to keep putting shameless plugs for the fact that we're going to try to keep those labs updated with more stuff as they come out. So when the team puts out new things, hopefully we'll be able to connect them here. Pablo asked, any recommended links for videos about using red teaming? I don't think you have any stuff on videos, but I'll let you answer.
No, this would be the you're watching it, and we're going to be using this link.
Yes, and I'll also put a shameless plug to say that we're just going to set up an AI tour theater session. So if you ever want to go and do the talk elsewhere, there'll be resources there. We'll share a link to that after the fact. Vikram Nanda asked, are there any Azure free labs to try and test it for learning and proof of concept purpose? Minsoo, are there any free labs?
Oh man, I don't know. Nitya, I feel like you're going to have to answer this one.
Yes, so the link is actually, if you're looking at the slides right now, this link is to Minsoo's blog from MS Ignite that she was talking about. Definitely grab this one. This is to the SDK itself for a sample. If you want to try out a sample with the latest SDK and just kind of like look at red teaming in action, the Learn documentation. And of course, since you asked, this is the link to the lab that we did at Ignite. Now, this lab is still not updated with the latest stuff released, for example, the prohibited actions, but it will be there soon. That's a good place for you to start, and we'd love feedback. Please do star and fork it. If we get to like 100, I'd be super happy.
Yes, please, someone make Nitya's day. I really, this can be our collective Christmas gift to Nitya, who works so hard to put this amazing educational content out on open source. And just for yeah, and just for the previous person who asked if there was a way to use this with agent frameworks, you could actually leverage this lab, which has the local experience, and then just swap out the callback function in the lab with your own agent frameworks agent.
That's true. Though I think the first one was the agent callback. And then there was someone who said, we have a team, and this is Pablo again. We have a team of agents appearing as a single agent in a workflow in Microsoft Foundry. Would red teaming only the agent? Would we be red teaming only the agent as a whole effective, or should we evaluate each agent separately?
We do recommend evaluating each agent separately. And then, yes, you could also evaluate the whole system-wide level, agent that is going to be a comprised of all of these different agents. But we recommend doing each of these agent pieces separately as well.
And I think that part of that is also, I'm guessing down the road, we'll all be reusing our agents a lot. So it seems to make sense that your agent will get reused in various contexts, so red team it first. And of course, number one thing I think we all have to take away is we need to shift left on red teaming. Like start red teaming the minute you plan anything. The next question was, after initial red teaming on a model or agent, once the application backed by model agent is deployed to production, should we repeat the red teaming scan often? Should we continuously red team?
Wow, this is also an amazing question. So with all of the new stuff that we were able to ship at Ignite, one of them, along with the demo experience you just saw, I couldn't fit everything in, by the way. It was just, we shipped too many things. But one of them is the ability to schedule your red teaming runs such that you can have them run weekly, daily, and be able to log all those insights alongside your evaluations, continuous evaluations results in Foundry as well under the observability, continuous observe for agents. So all of that is available as well.
And I'm just going to say this, Minsoo, you didn't know this, but Selvi Bala, who asked this, basically says he attended our session at Ignite.
Thank you so much for attending.
And then we have one final question. Bad Mr. 123 says, can I run custom prompts from a data set to test for jailbreak instead of having it generate?
Oh man, yes. In fact, as we, what we want to try and provide is out of the box, we're providing all of the data sets that you might need for red teaming, right? Because we know that not everyone is going to have their own curated set. We want to give everyone a baseline of here's what, you should maybe expect to start with. But we also obviously expect that people will definitely want to have their own custom red teaming set, apply the different attack strategies based on their own custom set. And so we do actually support, it's in our documentation as well, we do support for the local experience using your own custom C prompt. You just have to make sure it's in the right format to feed it into the red teaming agent.
I'll be another shameless plug and say on the screen, if you look at the last dot in the learning objectives, we have a sample that lets you use a custom prompt with a data set. So you could try the lab. That's there too. That was the thing that we were doing at Ignite. And I think that was the last one. Oh, Lee says, Pablo had a good follow-up question that I imagine worries many people because companies are using from external suppliers that have several agents. Is there an MS solution? Let me see if I can find that. Yeah. So Pablo had actually said, I imagine that and worried that people, because companies are using external suppliers, may have several agents. How do we handle that? Like, is there a solution?
So the worry is the external suppliers are using agents that you're not able to test,
Exactly.
right?
I think so.
Yeah.
Yeah.
I think that, that's kind of really difficult because you don't have access to the agent to try and do this red teaming. I would expect that this is something that you would, we're providing tools for people to be able to test when they're developing their own agents rather than testing other people's agents.
Okay, we have one last question, and then I'm going to let you go because I know you've been here a little longer than we planned for too. Pablo says, what about red teaming tools? I think this is a great question.
Like tools for with, yeah.
I'm guessing when he says red teaming tools, they're literally tools that we can invoke from our models, right? Like, would there be additional red teaming tools? Pirate itself is a tool, but I'm guessing that the reason I'm saying it's a good question is my understanding is there are two different issues at hand. One is, are there tools? But the second is also using red teaming in there's SLA and things like that. So the red teaming agent is actually approved to run adversarial attacks, right? So
yeah. Yes, I would say that the red teaming agent is, not a tool that an agent would be able to use, but it's something that you would integrate into your development lifecycle. So in that way, it's not necessarily a tool, but it is something that you should be using in your development lifecycle.
What I'm going to say really quickly is we need to kind of move on to the next segment, but please don't forget to join us on this Friday for a Foundry Friday AMA. So we'll have 30 minutes of Minsoo's time. I'll curate all these questions and bring them there as well. But if you had a chance to go look at the documentation sub-blog or the lab, bring them over and we will see her there for more questions. And thank you so much, Minsoo. This was really, really good and we appreciate it. Awesome. And so now I want to move us on to our next segment. We're running a little bit late, but hopefully this will be useful. We love this customer story segment because we really want you to understand how Microsoft Foundry and all these tools are being used in the real world. So this is from an Ignite story case. So let's roll tape.
All right. Good morning, everybody. Marco, thanks for that introduction. And he's absolutely right. Ada is probably a company that you've never heard of, even though our scale kind of speaks for itself. We process about 1 billion conversations, and we're automatically resolving. That means like deeply answering the questions in accurate and safe ways, about 54% of the time for most of our customers. We process over 1 trillion tokens monthly. The business has scale. And what's really interesting about Ada, especially after hearing Sethu's talk and all of the innovations that have come to bear on Azure AI Foundry recently, we're pretty much using every single one of them with the exception of Model Router. I would say everything there has been instrumental in running our workload, which is run entirely on Azure AI Foundry. The reason why it's important is that we typically deal with enterprise customers, and while we're a growing business and we're growing rapidly, so the number of customers that we're bringing on keeps on increasing month after month, our customers themselves are often growing. In this case, Tilt is a fintech. You may have heard of them. They used to be called Empower. Explosive growth coming there. And it becomes really difficult for anybody to predict the volumes and the demands of companies like this because they can get pretty bursty. If one of our customers suffers a cyber attack, or Black Friday is coming up, or there's some other event that impacts their business and causes customers to come to them with needs that are immediate and high urgency, we need to be there to answer the call, and our usage of inference on Azure has to really be up to the task. It's particularly interesting because we don't only serve text-based modalities like you have in a website chat or on a social messaging chat. We provide all of our services equally through one platform that runs over any telephony system or over email. So when you look at the demands that we have in terms of just scale of inference that we need to do, as well as latency, it really becomes a challenging engineering problem to tackle. One of the a lot of people that have built systems like this in-house, they think that building a customer service AI agent is pretty simple. We see them demoed all the time. You saw one of them in the first demo that Marco gave. And they're usually implemented as a single monoprompt that will receive the query from the customer, embed it in some system context, and spit out a response. Maybe it does some retrieval augmented generation in the middle of it to source some required knowledge, and that's it. You can't actually scale a product like that. To be able to offer customer support automation at scale, you need to actually break down from a single monoprompt and move to a more multi-agent architecture where you're able to take a diverse set of instructions and procedures and policies that companies provide and that they give to their human agents, and ensure that the software agents you're building are able to follow those procedures. So not only are they able to retrieve knowledge and provide an answer, but they need to be able to follow appropriate steps, stay in compliance with laws that can vary by region to region. They need to use tools judiciously and appropriately. All of this means that between every utterance on the phone or every message sent into those chat boxes, you're likely running 3, 4, 5, even 10 inference calls behind the scenes. And dealing with the demo that Sethu showed was really great, because he showed you like that user frustration index, right? Like if any one of these responses, particularly when it's happening over the phone, where your caller is stressed out, is upset, it's a sensitive situation, if you're not able to get back with an accurate response quickly or fill that dead air, you're going to create a negative perception for that brand. So what we've been able to do at Ada is through use of provision throughput units, plus now priority processing, and then all sorts of tricks in terms of how we're leveraging cache tokens, how we're using batched operations for analytics that's happening behind the scenes, and so much more, we're able to deliver pretty consistent performance. And I would say over our journey with Azure now, which is coming up on almost 3 years of working together as a partner on this, we've seen performance through model generations, but also through enhancements to the underlying platform really deliver and help us get to our 1.3 trillion tokens per month scale. That's probably going to scale up to maybe about 20 billion tokens in total next year, just to give you an idea of our growth rate and what that looks like. Sorry, 20 trillion. What does this let us drive? Well, at the end of the day, I tell my team of builders that we need to beat the human at providing customer service. This means two things. One, we need to resolve more often than a human agent can resolve when you just hire them. Take an average contact center agent that you'll recruit in a BPO, in a business process outsourcer. Benchmark in the industry is 70% resolution that this individual can achieve within their first few weeks on the job. Our best customers are seeing our AI agents resolve 84% of the time. We're also cutting the amount of time it takes for a human agent to resolve inquiries when they're escalated by 42%, and just driving up the amount of capacity that our customers have to be able to deliver support. End of the day, customers that are using Ada, that are using this technology that's built on Azure AI Foundry, are able to break that dependency between cost invested in support, or like dollars invested in support, and quality customer experience because of these metrics. And then just to kind of bring it all together, like we're continuing to invest in Azure on AI Foundry to keep on broadening and increasing our workload. We're doing a lot with fine-tuning already for certain labeling and analytics tasks. We're driving this up in other places where we're going to smaller models in very specific parts of our inference chain to be able to improve accuracy and reduce cost. All sorts of things in performance optimization, both in terms of how we provision and manage load on PTUs, how we're doing automatic spillover, how we're thinking about priority processing as part of the stack, and how we're discerning between modalities. Obviously, we can have different SLOs between an email response and a phone response, and we're getting a lot better at performance optimization there. That comes with cost optimization as well. As we've brought up this scale on in terms of overall tokens that we're processing, we haven't seen our costs increase linearly. In fact, as we've increased the number of tokens that we're putting through on Azure, we've been able to control our costs so that it grows at a slower rate than the actual bandwidth of inference. And that's been key in working, I think, on the support side of this, where the team has been really eager to support us, not just in our growth, but also cost management. And finally, just scale and stability. We came to Microsoft, to give you an idea of timing, we came to Microsoft and invested in this relationship when there was the famous weekend of drama with Sam Altman getting ousted from OpenAI, and we were worried that we wouldn't have a partner to rely on. We already had customers that were relying on our technology. We came to Microsoft really quickly. We spun up really quickly, and since then it has been a mountain of stability for us, and we're really happy to have it. So thank you very much.
Awesome. So thank you all. And I hope you were able to catch the session last week, because both sessions come from this Ignite session that you see right here, if you grab the QR code. And both of them were looking pretty much at the techniques you'd use to scale in production. So if you want to go check that out, you will find out some of the priority processing and all of those are actually covered there. And with that, we're kind of going over a bit, but I want to spend a few minutes just giving a little bit of another preview intro to the Models for Beginners curriculum. This is something I'm working on right now. We'll have one more episode in December, and then we'll be back in January. So this is kind of, think of this as a pre-season preview of like episodes as I'm writing them. And then hopefully when you come back in January, you'll have a whole curriculum that you can play with. But I wanted to give you a little bit of a sense. And if you like sketch notes like I do, this is telling the story of what Models for Beginners is. And we're going to get into large language models first. So stick around and let's see if we can walk through this really, really quickly. So the first thing I want you to talk about is what is Models for Beginners and what is the learning journey I want you to go on. So let's look at the big picture before we dive into the first lesson. So the big picture for Models for Beginners is really that when you build anything on AI, you actually need to think through the implications of first the development environment you're on, then the models that you want to use, how you pick the right model for the job, how do you customize the model to meet the requirements of your application? And finally, most important of all, how do you manage that model in post-production so that you're optimizing for cost, reliability, safety, and more? So today, I want to actually set the stage for the lessons and labs that we will start releasing over the next few weeks. It turns out that I'm an educator. I really like helping people learn. And oftentimes, it's easiest to learn when you have a use case scenario. We talked briefly about this, that our application scenario is going to be an enterprise retail scenario. We will actually have two data sets, the Contoso chat data set and then the Java retail data set, both of them showing you products that you could use. But today I want to tell you briefly about what the requirements are for that app that we're building, right? So first, you want it to be using natural language. We want to build a customer support service bot. So it should be speaking to the user exactly the way a customer service agent would do. This ties into what we'll talk about in language models in a second. Next, polite and helpful tone, which means we do need to make sure that it kind of reflects the Java brand or the Contoso brand in customer service. Factual and relevant information grounded in that product data. So store inventory is changing. I need that in real time. It should be cost effective. The bot should not be more expensive to operate than the products it's selling. And last but not least, safe and trustworthy AI. So the journey I want to take you on is really to kind of help you understand today what the development environment for the curriculum will be and how we want to set you up for success. So for the development environment, we're actually going to have two different things that I want you to focus on. One, I want to think about configuration as code. Your development environment is a dev container. The repository will be is instrumented with a dev container that you can launch in GitHub code spaces. It has everything that you need. We are making the decision to get everything working with Microsoft Foundry from the start. So this will have all the SDKs, the Visual Studio Code extensions, and more set up. And what configuration as code lets you do is take advantage of the fact that every time we make changes to any of the Python libraries, tools, etc., you just have to relaunch it and you're going to get it out of the box with no additional effort on your side. That takes care of your development environment. We're going to use the same kind of philosophy for the infrastructure, using something called infrastructure as code, and specifically AZD templates. So what is an AZD template? If you've ever worked with Azure, you've got to deploy resources and an architecture in order for you to then connect to that back end using environment variables to do something meaningful, right? And that's really complicated for many of us. What AZD does is it allows you to store that configuration as files in the repository, and we have a standard template that we'll use, and then use a single tool to simply provision the whole thing with no additional effort on your part. So already, I want you to kind of keep those two concepts in mind. We will support infrastructure as code and configuration as code. But well, we're not done yet. So if you have your development environment set, you have your infrastructure set. So how are you actually going to build? So a lot of the courses that you'll see out there are going to teach you how to work with a single model or how to do something that tries it out with an individual lab. We actually want you to use this course as an evergreen journey that will take you from your very first plan to production. That means we need a platform that will give us all the features and tools we need, and that's going to be Microsoft Foundry. And I specifically want to point out 4 things that we're going to try to help you learn. First, model choice. We have 10,000 plus open source models and a lot more of the frontier models. So in this curriculum, we'll cover frontier models, of course, first. Take a sample of some of the open source models from Hugging Face, but most importantly, also look at smart models like the model router that'll help you pick the right model for the job automatically. We're going to have 2 approaches. Design first, where when you're planning, you start in the portal. You don't need to know how to code. Start in the portal and start from there. Adapt to your application. And then when you're ready, move over to code first, where you then move to the development environment with an SDK. And we'll show you how. And last but not least, one of the core areas of this course is going to be model customization. But let me tell you about briefly while we walk through the 4 tracks. So in track 1, when you think about models, we actually have different kinds of models. We're going to start with language models today. But once you know what a basic language model does, then you need to understand specialized models like multimodal, where you're bringing in media, reasoning models, where you're letting it think and plan for you, and smart models, where you're letting it route. So in this particular track, we'll have 4 lessons with probably an ever-growing series of labs that will help you try these out with different instances. But we'll talk about these 4. Model selection, we're going to look at it specifically from a design-first perspective going into Azure Foundry. So Microsoft Foundry. So we're going to start by getting you to deploy a model into a playground, try out sample prompts, then go and look at the leaderboard to compare how 2 models work based on cost and accuracy. And then you're going to go into other techniques like using evaluators of your own or using the built-in capability to take you into code. Once you've got into code, customization. And this is where we move from beginner to intermediate. So until A and B, we're really going to be doing more of a entry-level content. But when we get to C, we're really starting to go into intermediate, where we'll teach you how to do 3 things. 1, context engineering, which is actually both prompt engineering and a little bit of RAG. It tells you how to use the context window in your model effectively. And then we're going to look at the fine-tuning part of it, which is going to tell you how to change the behavior of your model with supervised fine-tuning and other techniques, including distillation. And last but not least, none of this matters in production if you cannot build trust. And so if there's one thing I wanted to think of, we'll end with a 300 to 400 level track or mini course that is going to teach you all the core features and tools for end-to-end observability, which is tracing, evaluations, red teaming, monitoring, and application insights across the whole thing. A lot of you have come and asked me, hey, when is the repo going to kind of go public? I'm working on it. I wanted to give you a sneak preview of a little bit of that, and I might actually just release some of them early. I have a summit coming up this week, so fingers crossed. But today I want to just give you a sense for where or how these lessons get structured. So the first lesson we're doing is language models. Now, all of you have used language models. You're probably thinking, I know this stuff, like what is new? What I really want to do is have you have a different mindset when you approach this. So when you look at model fundamentals, this is track 1. The first thing in this lesson is going to be, what are language models? Why are they key to AI today? A lot of us know how to use them, but we don't really know why they're such a big deal, right? And then finally, how do they work? So first and foremost, if you haven't already done the Generative AI for Beginners course, that is the QR code for that. Hugely recommend you take it. That's the one that'll give you kind of a 100-level course, kind of like concepts, view of the space. But when I look at models for beginners, I'm going to look at it from an engineering model development perspective. So what are large language models? To answer the question, you have to understand how artificial intelligence has evolved over the past few years. I really love this picture from that curriculum. When you start with AI, you're really thinking, how can computer science, how can these things that you're building allow you to have machine intelligence that can keep pace with human intelligence? Machine learning itself is really about that subset of AI that helps the machines learn, building these models, building these learning functions. Deep learning takes it a level higher, where you're looking at layers of neural networks that mimic the human brain, and you can kind of have it do more complex actions, predictions, classification, etc., and make decisions. But it all came to a head 2 years ago, because we're saying, why are they so big? Why is large language models such a big deal? Generative AI started this trend where AI was able to create new content. And that's kind of where it all started. So why large language models? Just look at those 3 words. The key is the use of language, natural language. Your prompts, the words you say, are now the API for a whole new ecosystem of applications. That means your words have power. So generative AI is when you use your words to create content. Agentic AI is when you use your words to tell the agent what to do and have it execute tasks in an automated manner without your presence. And the breakthrough for both of these is the fact that we were able to go from simple completion tasks to instructions where your models are fine-tuned to understand that the words you say are not just about predicting the next token, but potentially identifying a hidden task and executing it. So if I have to like summarize this, right? Someone asks you, what's a large language model? Large because they're trained on massive sets of data in the internet. That makes them general purpose, and you'll see why that's important in a second. Language because they're using human words, which means anyone is now a programmer if they can just speak the task they want the AI to do. And finally, model because it's a learning function, a transformer architecture that is able to take the word input you've given and predict the next token and the result based on whatever you're trying to get it to do. So why are they transforming AI? You're probably wondering, why is it such a big deal? AI and models have been around for a while. I want you to think of this onion peel diagram. At the heart are models. Models, when they are born, have a certain amount of knowledge that they know, and they can answer questions, etc., by predicting statistical analysis. We'll look at that in a second. But it's only when we attach tools to them that suddenly they're able to enhance their capabilities. You can use tools like knowledge retrieval to bring knowledge that the model did not know. You can use tools like API integrations to bring capabilities that the model does not have. And once you have these two and you wrap it in an agent, which can then do those decisions on your behalf, you have the ability to build really powerful solutions. And so the real revolution, and if you have not read AI Engineering and you have not bought it, it is one of the fundamental books that I suggest you get over this holiday season and read it. It will transform the way you think about AI. So the main thing is that you don't need data scientists in your organization anymore to build a machine learning model. Previously, if you had to build a machine learning prediction algorithm or a recommendation system, you needed people who understood data, who could build that model for you. Now, you can shop for a general purpose model that can speak natural language, start with that, and then pretty much just enhance it. So customize it with your data and your actions. And that is what is bringing AI to scale. So when we think about it in our retail use case, what I really want you to keep in mind for the rest of this season is that in models for beginners, we're going to use a retail use case. Where I am is I'm going to go to this AI and say, hey, I'm painting my living room. What should I buy? And it should come back to me and say, that's a great choice to paint your living room. I recommend this paint from our catalog. And would you like to know more about it? How do I get from this question to that answer is really the whole purpose of this course. How do we get started? To know this, we have to today, I'm going to end with just telling you how do language models work. My goal is not to tell you everything. You have to be able to explore this on your own. So I want to give you resources, but the curriculum will also be set up with prompts for Copilot. So as you go through it, you can ask Copilot questions and then go down the rabbit hole as deep as you want to go. But to start with, how do large language models work? You want to think about it from two keywords, self-attention and transform architectures. And it all starts with tokens. So when you think about language, the basic principle, and you'll have read this if you've ever done anything in generative AI, is that when you say something like, I'm painting my living room, what should I buy? It breaks it up into what's called tokens, because the AI does not actually understand the meaning of those words. It just sees them as numeric things that occur frequently in that large corpus that it was trained on. So it takes a sentence and it breaks it up into tokens, as you can see here. If you go to that QR code, you can try that tokenizer out for yourself. So now I have a sentence that I understand in English. It just has a series of tokens, numbers. And now it has numbers like this for everything in the world. Then it goes to work. It says, okay, given this length, given everything I know, let me then figure out what is the relationship between these tokens that gives me context about what this user is trying to do. Hugely recommend going to the article on the right side where you see the QR code. It will literally take you through a visual story of how transformers work. But the basic idea is, once you have these tokens, it knows it can predict the probability or the relationship, the weight of the relationship between two words. And it can start predicting the probability that if this happens and this happens, what could happen next? And that's pretty much the sense of self-attention and transformers. Self-attention says, in my context window, I will understand how the words or the tokens in here are related. And the transformer architecture says, given this, and I know the weights, I can predict the next word and keep transforming your input into the output one step at a time. If you understand that core concept, you have actually understood the basis of large language models. And then when we dive into actually trying them out in labs, you can pay attention to token counts. You can pay attention to how changing the sequence of words or the length of the sentence or parameters actually changes your output. So I want to leave you with one final thing. How can we get hands-on? So in this curriculum, we're actually going to take 4 different kind of routes. We won't do all of them at the same time, obviously, but I want you to be aware of your options. First, GitHub models. We'll look at that in a second. Second is Foundry models. So pick your model playground for your initial exploration, GitHub or Foundry. Once you get past level 200, which is track 2, you cannot use GitHub anymore. So you'll use GitHub probably if you want to explore the first track, but you really want to go towards Foundry models. And below, again, design first versus code first. Design first says, don't bother about getting into code immediately. Play around in playgrounds with UI until you get to a point where you have a good idea of what you want to do, and then move to code first. And we'll show you all of these in the labs, in the curriculum. But today I wanted to just get a sense of how you could get started on your own right now if you want to understand how these language models work. So let's revisit our use case, right? If you want to start with GitHub models is available at the QR code that you see here. And I actually have it staged in my browser right here. So this is what GitHub models looks like. It has pretty much all the popular models that you want from various providers. It has different capabilities, different categories, and more. And once you select a model from here, you will actually be allowed to go into a playground and try it out interactively. It's free to use. All you need is a GitHub account, but it's rate limited. You can only do so much. But let's take our Java use case and see what happens. I put in, hey, the system prompt. I'm describing to this model what its persona is. You are a helpful and polite customer service assistant for Java. I'm going to ask you a question, please answer it. And I'm going to put this question. And you'll immediately see, now that you understand how language models work, you'll understand that it chunked this up, it tokenized this, and then based on what it saw were the critical parts of this and the connection between them, it started writing out the results. And in this particular case, it's done a good job. It's coherent. It looks human. It looks like something a human would write, but it's not actually grounded, as you can see. It's not really talking about Java products. We'll fix that in a future lab. But it gives you a sense of how you can start using it. You can work through the things like the configuration parameters, understand the cost, the input token size, output tokens, and the latency, etc. That's GitHub models. But the other thing which we really want you to go towards is Foundry. So with Azure, with Microsoft Foundry, the same model catalog that GitHub models uses comes from Microsoft Foundry. They're backed by the same models, except with GitHub, you're seeing a small subset of them. With Microsoft Foundry, you get the whole lot. So here is what the Microsoft Foundry catalog looks like. I've actually tailored it down to just a few, but you can see that it has a lot more collections, has a lot more tasks. You can even select them for fine-tuning and so on. I've picked the same OpenAI collection here. You see we have a lot more model choices. But more importantly, when I use this in Foundry, I get 3 things. 1, no rate limits, because I can actually use this. I'm going to be billed for it, but you can use serverless or managed, and you can kind of look through the pricing. For the labs, we're not going to try to do anything intensive. But it is something that you can basically use in production later. Second, the integrations. you get an end-to-end platform where you can go from planning to evaluation to building to deploying to monitoring, etc., as you can see on the left side, all in one place. Third, design first versus code first. If you switch into the new Foundry model right here, you will get the new Foundry experience, which, let me see if it's still there. You'll get the new Foundry experience, which will actually reflect a design first development workflow that will be much easier for you to follow through. But for now, I'm going to move over to where we deployed the model and look at the same thing that we did with GitHub models over here and see what additional things you get when you play with Foundry. So here I've set the system prompt. I've given it the same question, but now I can do a bunch of different things. When I finish this, it gives me the token counts, but it also gives me the breakdown. It allows me to do additional things like add data, set up few-shot prompting, generate system prompts for me to be more efficient in how I use that's context engineering, and so on. So with that, I'm going to actually stop here because I wanted to set you up for what we're going to do. And this kind of, if you've got this far, this is basically the basis for what Models for Beginners is going to go into. You know what language models are. You know the platforms we're going to use. We're going to start from understanding all the various model families you see. And then we're going to work through our development lifecycle from planning to selection to customization and observability. Next week, I'm going to do a really sneak preview of the second lab. Hopefully by then, I'll actually release the first one that you can try out in the repo. But next week, we're going to ask this question. Okay, so language models allow you to have a text input and get content generated as text. But what if my Java customer actually brought a photograph and said, can you match the paint in this picture? What would we do then? Or what if they said, can you show me what my a kind of like a really nice gazebo would look like based on what you have? The ability to extract information and classify images or generate content, all of those require multimodal. So we'll look into that. What are they? Are they popular today? How do we use them in practice? And then we'll kind of look at a couple of tasks in that context. But with that, I'm going to kind of stop this over here. And I'm going to take us back to our original thing. This is the entire curriculum. The URL at the bottom, the GitHub repo, is the one that you want to keep an eye on. Hopefully, we will have that public very soon. I will tell you that the issues will be turned off till January because we're all on vacation and I don't want to be able to back up things that can be maintained. But you should be able to meet us on Discord. So go to ak.ms/modelmonday/Discord. Come chat with me there if you have any issues or questions, and we will talk that through. Don't forget that we have our Foundry Fridays AMA this Friday on Discord as well. You can use that QR code to join us right there. And come talk to Minsoo and me. And absolutely, please do try the lab we had at Ignite and bring your feedback. We want to make that better. And finally, what's next? So the next week will be the last of the Model Mondays episodes in December. We will be joined by
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.